Okay, welcome to Skill 6, adding and subtracting rational expressions. So last time we did multiplying and dividing. Today we're going to go to adding and subtracting. So if I were to normally give you a fraction, how would you add this? So they have common denominators. So the denominator stays as 2, and then I add the numerators, and then I simplify what I can. So if I gave you something like 4/7 plus 5/7, they have common denominators. So the denominator is 7. 2 plus 5 equals 7/7 or 1. We're going to keep this idea in mind as we go on to add and subtract rational expressions. So you want to be taking these notes as we go. If you have questions, or if you want to label by the slide number on the bottom left or right, that's a great idea to keep your notes organized. So the first question we're going to ask ourselves when we see this is, do we have a common denominator? The answer is yes. So my denominator is just going to be 4c. Then I have to think about, I have this negative sign in the front. So I perform whatever operation it asks me to do in my numerator. So from here, it's just the nitty-gritty of simplifying the top. I'm going to go ahead and show that work down here. So with that negative sign that we see there twice, we want to make sure to distribute that. And then combine like terms. So my c's, I end up with negative 13 c's. And my d's, I end up with 14 d's. So this is simplified. I think, can I simplify this further? Even though I have these c's here that we may be tempted to cancel out or reduce, I cannot, because think of this whole thing as grouped together. So I can't just take parts of there, I need to take all of that. So we'll go ahead and go on to the next slide. Okay, this one, we can see again that we have common denominators. So I want you guys to try to write this. What would my denominator be and what would my numerator be once I added the two different numerators that I had? So go ahead and try to simplify this on your own. Okay, we should have gotten our 3c plus 5 is our denominator. We don't need to multiply or anything fancy or add them. That is our denominator. And then we'd add our numerators, c plus 1. I cannot simplify that any farther, so that would be our final answer for that. This is the same idea, adding and subtracting rational expressions. So we have a subtraction sign, simplify your answer as much as possible. So we need to go back to remembering this chart that we have. Remember, the first step for factoring is looking for the greatest common factor, because in the problem we were just looking at, we have a trinomial, but it's b squared, so it's a quadratic. So I have common denominators, but I could simplify it a little further. A times c is 10. That adds to our b of -7, so I'm going to do -5 and -2. Where I end up with so this is what the numerator can be for both of these. I want you guys to, on your own, pause and try to think through how you would do the top. So go ahead and pause, think through how you do the top and how to simplify this. Okay, you guys tried it on your own. So we would have b minus 2 would be our numerator. Those would cancel out. I still have a 1 in my numerator. And this is what my final answer would be. Yay. Now we're going to think about what we would do if we don't have common denominators. So 2 and 4 are not the same denominators. So what they both need to be is, we want them both to be a 4. So I'd multiply this by a fancy 1 of 2 over 2. This would now become 2 over 4 plus 1 over 4. And since it looks like that now, guys, I'm going crazy. This would become 3 over 4 because I add my numerators. If I looked at this, I have a 7 and an x. So eventually, I need my denominators to have both a 7 and an x. This first part has a 7, but doesn't have an x, so I'd multiply by a fancy 1 of x over x. This has an x, but doesn't have a 7. So once I do that, this would look like 2x over 7x plus 21 over 7x. Now that my denominators are the same, I can add them to get that. So when we don't have common denominators, we make the denominator the least common multiple. So by least common multiple, we need, what is the smallest number that both 7 and x go into? What is the smallest number that both 2 and 4 go into? So we're going to practice that on these next few slides. Okay, so what's the least common multiple of 4w to the 4th and 7w squared? So if we think of it, the least common multiple is what we'd use to make the least common denominator. So if, in other words, if I showed you something like this, what would the denominators need to be? So let's just talk about the w's first. We have 4 w's here and 2 w's here, which would mean everyone needs a total of 4 w's. So we give this one 2 w's. Now our w's are good. 7 and 4, what is the smallest number 7 and 4 both go into? Are 21. So to get, 28. Yep. So to get both of these, this would need a 4. This would need a 7. So I'd end up with a denominator of 28w to the 4th, and these least common denominators are the least common multiples. So you guys are going to go ahead and I'll start you guys on this one, but you guys are going to think through the rest of it on your own. So if you saw this as like 1 over that and this, what would everyone need? So go ahead and think through that, pause the screen, think through that, and then I'll talk through an example, or I'll talk through it once you guys are done. Okay, so let's start with our 16 and our 4. That means that both sides at least need to have the smallest number that 4 and 16 both go into is 16. So that means this side would need a 4 over 4 to get it to 16. If we look at our x's, both sides are good on x's. If we look at our w's, this side needs 5 w's, not 6. So both sides need 5 w's. And if we look at y's, the 7 and 6, this means both sides at least need 7 y's. So what our least common multiple or our least common denominator would be is 16. I have 8 x's. Everyone needs 5 y's, and everyone needs 7 z's. Or 7 y's. I was thinking x, y, z. You guys are doing great. Okay, so I want you guys to take a second to yourself. I want you guys to multiply 2 and 5. What is the least common denominator that they both need? So what is the smallest number that 2 and 5 both go into? Let's go ahead and think about that. Go ahead and pause your screen and fix that. Do that. Okay, they would both need to be 10. So this needs a 2 over 2. This needs a 5 over 5. This asks us to actually simplify our answer as much as possible. So we're actually going to do the math. We have 10y or 5y over 10 plus 18y over 10. And this is what we'd end up with. Okay, so we do not have common denominators here, so we need to think through how to make common denominators. 2x and 6x, they both have an x, so the x's are good. But I want you guys to think through what we need to do to make them the same. So go ahead and take a second to think about that. Pause your screen. What we need to do is get 3 over 3. It is asked us to simplify, so I'd have 6x. And then I can distribute that 3. I'd have 12x minus 27 plus 6x. Ooh. Okay, now I can combine, because I have common denominators, I can combine, so I have 12x and 5x and 1 and negative 27. I can simplify that. Go ahead, pause your screen, simplify it on your own. Okay, this is what we should have ended up with. Okay, I want you guys to try this one on your own. Think about how to make your constants the same, how to make your x's the same, and how to make your y's the same. So I am going to look at my constants. This at least needs a 2 over 2. I'm going to look at my x's. Everything at least needs an x squared, so I'm going to give this an x. Everything at least needs a y to the third. So I'm going to give that 2 y's. Then we can go ahead and rewrite it. And I see that my denominators are the same now. And then I can continue to add across my numerators because my denominators are the same. Okay, we're going to have a second video here, so go ahead and take a break if you need to. But we're going to move on to the second video for this skill.